Today, we're doing something a little different. We're not just going to talk about some boring math concept. Nope. We are actually building a powerful toolkit. We're going to take factorization, that thing from your textbook, and turn it into a set of go-to tools for tackling really complex problems. Okay, so let's kick things off with a bit of a puzzle. You look at a simple number, right? Like 6. And then you look at an algebraic expression like x squared minus 9. I mean, they seem like they're from totally different universes, don't they? But what if I told you they actually share a pretty big secret?
And here's the secret. You can break both of them down. Really break them down into their most basic core parts. And that idea right there, that's the master key. It's what's going to unlock this whole toolkit for us.
Okay, so if we're going to deconstruct anything, we can't just wing it, right? We need a plan, a blueprint, and that blueprint is factorization. So what is it exactly? Well, think of it as the master plan for making sense of all this stuff.
So here's the textbook definition, but don't worry, it's pretty simple. Factorization is just the process of figuring out what things you can multiply together to get the original number or expression. It's kind of like multiplication, but in reverse. Instead of building something, we're taking it apart to see what it's made of. And this really shows you what I'm talking about. Look, on the left, you've got 6, which we all know is just 2 times 3. Simple. Now look at the right. That x squared minus 9 thing, it's just x minus 3 times x plus 3. See, it's the exact same idea. We're just applying it to something that looks a bit scarier. All right, we've got the blueprints. So now it's time to start filling up our toolkit. And, any good toolkit has to start with the basics, right? These are your foundational tools, the ones you're going to be reaching for again and again for most of the stuff you run into.
First up in our toolkit is the common factor method. And I want you to think of this one as your screwdriver. Yeah, your trusty screwdriver. Why? Because it's super versatile. It's absolutely fundamental. And honestly, it should pretty much always be the first tool you grab.
Let's see this thing in action. Take a look at 6x squared plus 9x. So you just look at the two parts and you ask yourself, okay, what do these guys have in common? Well, you can divide both by 3, right? And they both have at least one x, so that's our common factor, 3x. We just pull it out front, boom, simple but so effective. Okay, next tool for the kit. This is our adjustable wrench, factorization by grouping. Now, this one's a little more specialized. It's not for every job. It's for that very specific moment when you're looking at an expression and it has exactly 4 parts, or 4 terms. And the way it works is actually pretty cool. You just group the first 2 terms together and pull out whatever they have in common. Here, it's A. Then you do the exact same thing for the last 2 terms, pulling out the B. And then, like magic, you suddenly see a new common factor pop up, that x plus y. You just pull that out to the front and you're left with the final answer. Okay, so we've got our basic hand tools down. We've got the screwdriver, the wrench. Now, it's time to break out the power tools. These are for the jobs that need to get done fast and get done right. We're talking about algebraic identities. These are like cheat codes that let you solve certain problems in a flash. The first power tool is the difference of squares, and this one is awesome. Anytime, and I mean anytime, you see one squared thing minus another squared thing, just like that first puzzle we had, x squared minus 9, you just know. You see the pattern. It's always going to be a minus b times a plus b. No thinking required. It's a massive time saver. And then there are the perfect squares. Again, this is all about spotting patterns. If you see something that looks like a squared plus 2ab plus b squared, a little light should go off in your head. You immediately know, hey, that's just a plus b squared. Recognizing that pattern saves you so much work. And for those really heavy-duty jobs, we've got the sum and difference of cubes. Now I know, these look a little intimidating, a bit more complex, but guess what? They follow a super strict, totally predictable pattern. Once you know the pattern, you've got this power tool in your back pocket, and even those tricky cubic expressions become, well, pretty straightforward. So look at our toolkit now. It's getting pretty full. We've got all these amazing individual tools. So let's stop doing small repairs and move on to a full-blown project. Let's see how we can combine all these skills to tackle some bigger, more complicated stuff. Okay, let's imagine we're on the job site. And here's our task. We need to factor a quadratic expression like x squared plus 5x plus 6. And this is a big deal, you know? This isn't just random math. These kinds of expressions are used for everything, like predicting the path of a baseball or figuring out business profits. Now, if you look at it, it doesn't immediately look like one of our power tool patterns, so we're going to need a different approach. So here's the trick. you look at the last number, the 6, and you look at the middle number, the 5. The puzzle is to find two numbers that, get this, multiply to 6 and add up to 5. So let's run through the options. 1 and 6, they multiply to 6, but they add up to 7. So, nope. How about 2 and 3? Well, 2 times 3 is 6, and 2 plus 3 is 5. Bingo, that's our magic pair. And seriously, once you find that pair, you're pretty much done. The job's finished. The expression just becomes x plus 2 times x plus 3. See how that works? We just turned what looked like a confusing puzzle into a simple, step-by-step process.
Let's add one more really cool tool to the kit. This one's kind of like a special diagnostic tool. It's called the factor theorem. And for those huge, messy polynomials, this thing is an absolute lifesaver. It basically says this: if you can find a number to plug in for x, let's call it a, that makes the entire expression equal 0, then you automatically know that x minus a is a factor. It's an incredible shortcut. You know, it's one thing to have a great toolkit. It's another thing to know which tool to use and when. That's the difference between an apprentice and a master craftsman, right? It's all about strategy. So let's talk about the pros approach. So here it is, your master checklist for literally any factoring problem you ever face. Step 1. Always grab your screwdriver first. That means always check for a common factor before you do anything else. I mean it, always. Step 2. Quickly scan for a power tool opportunity. Does it look like a difference of squares? Is it a perfect square? Use those shortcuts. And step 3, this is crucial. Check your signs. Be so careful with the pluses and minuses. A tiny mistake there can throw the whole thing off. And just like that, there you have it. We started with a simple little puzzle, and now look, you've built a whole factorization toolkit from the ground up. You've got your basic tools, you've got your power tools, and most importantly, you have a strategy, a real pros approach to breaking down complicated math problems into simple, manageable pieces. So I'm going to leave you with this one last thought. This whole skill, this idea of taking a big, scary, complex problem and breaking it down into its smaller, easy-to-handle factors, that's not just for math, is it? So now that you have this amazing toolkit, I want you to think, what else in your life, what other big problem can you start to break down and solve?